cosine or arc cosine? Which should I use? Inverse cosine? Arc cosine? Okay, they mean the same thing, but... So, there's like one of the solutions. And you have to add a thing to account for the periodicity of cosine. What do you add to that to get an infinite family of solutions? 2 pi k. But that's like half of the solutions, right? Since inverse cosine will give you that number. Adding 2 pi k will give you that number. In the meantime, you've missed those answers. How do you get those ones? Negative of the previous one. Let's play the same game for sine. What's like the obvious solution for sine of x equals c? Inverse sine. And sine is also 2 pi periodic, so 2 pi k's will get you an infinite family. And that captures all of the solutions that you see where the graph of sine of x is increasing. So it'll get you the going up solutions, but not the going down solutions. How do you get the other half? Yeah. And that's, so since what you said was pi minus that whole thing, that means you have like parentheses there. Did you mean parentheses there? Yeah, so I guess here's the trick. That would just wind up with a minus in front of the plus 2 pi k. But k is allowed to be any integer, so you would just be listing the solutions in the opposite order that someone else would. But that doesn't matter, you still list all the solutions. Parentheses not on, but also not necessary. Cool. People feel good? And of course there are caveats here. If the number c is like 7, can you do this? No, cosine is never 7, so sometimes there are no solutions. If c is equal to plus or minus 1, then like you can use this, but you'll wind up with like repeating yourself. Inverse cosine of 1 is 0, plus or minus 1 are both 0. Plus or minus 0 are both 0. So when you have the c is plus or minus 1, you should do something very slightly different. So here's what we're going to do. We're going to use these facts to solve equations like that. And let's begin exactly there. If you want to solve 3 sine of x plus 2 equals 1, what seems like a good strategy? Bring the 2 over seems like a good start. So what's like, tell me, that's definitely a correct thing to do, but tell me why is it a good thing to do? What's your overarching strategy? Yeah, let's get sine by itself, because then the equation will look like this, and then I can do that. So here's the goal we'll have. Let's try to get sine on its own. I agree, subtracting 2 from both sides seems like a good idea. So, in fact, I don't know, like, should I do any of the work for just getting sine of x on its own? Should I? Okay, then I'm just going to pause for a moment. Tell me, what happens when you get sine of x on its own? What do you get? And you're a negative 1/3. People agree? Awesome. Can we now just like appeal to the thing on the board to solve that? Yeah, I think so. Absolute value of one thought is not bigger than 1. So it's not like it's out of the range or anything. So to solve that, the obvious solution is inverse sine of negative 1 third. Oh yeah, absolutely. Inverse sine of negative 1 third plus 2 pi k. Pi minus inverse sine of negative 1 over 3 plus 2 pi k. So there's 2 infinite families of solutions, and they're there. They're just handed to us. A thing we should worry about is maybe simplifying. So I guess the first is inverse sine of negative 1 over 3. Is that an angle that you just already know? Look at your unit circle if you need to. So I guess it is negative 1 over 3 of y value that you see on that lookup table. It is not. Okay, so that means you can't just like replace it with something like pi over 6 or something. That's fine. Is there any other simplification I can do to it? How about that negative sign on the inside of the inverse sign? Is inverse sign even or odd or anything nice like that? Remind yourself what the graph of inverse sign looks like by maybe flipping to a previous page in the notes. Like the one where we graphed inverse sign. So there on page 143 is the graph of inverse sine. Is that even odd? It's odd. Okay, cool. Cool. That's all I wanted. So can I do anything with that minus sign? Could pull it out front. And this isn't apparently a major improvement. But it's nicer to have a negative sign outside of the parentheses instead of inside. And I think the next line improves a little bit more if I pull that negative sign out. Because now I see minus inverse sign. Oh, so that becomes a plus. Cool. That seem all right? Think you could follow the similar steps on that second problem? I phrased that wrong. Solve the second problem. And I'll give space for both of these conclusions. This isn't a test, you can talk to each other. I guess some of you don't really have like people nearby to talk to, but you can move if you want. The seating is not assigned. Coffee upstairs. monitor on anyone's way to see things that matter on the screen? It's definitely in your way. Best I can do. I think that's the best I can do. Cool. So, let's hear it. When you just solve for tangent of x, what do you get tangent of x must be equal to? I think I heard a negative of fifth. It was through a yawn though, but people agree? Okay. All right, if tangent of x is negative 1/5, then what must x be?